All right, here's another, welcome back folks, welcome back. Here's another example of a voltage divider for you. It's going to look a little different, but we're going to restate it so that it ends up looking like the other problems we've worked with. But you may run into a voltage divider that looks like this, and you have to stop and ask yourself the same questions and think about how to apply the formula. It's one of these canned formulas that takes a little thought, even though it's a canned formula. Okay, and it's going to look like this. Okay, so this is a voltage divider, whether it pops out at you or not. It is. I did a couple of things. We have a labeled voltage. We have labeled voltages all over the place. 15 volts, plus 15 volts down here, minus 15 volts down here. And we had talked about these when we were talking about voltage supplies, but you may run into these. If you go study analog electronics, having a split supply like this, where it's 15 volts on one side and negative 15 volts on the other, is pretty typical, and that comes from needing to drive a speaker. When you drive a speaker, let's see if I can line this up with the camera. There you are. If you want to push it out, you might have a positive voltage. If you want to pull the speaker in, you might have a negative voltage. And by pushing it back and forth like that around 0 volts, you can create a sound wave with the speaker. So very typical of circuits like that. If you're using Wheatstone bridges for strain gauges and things like that, you might want to center them around 0, and you're going to have a split supply similar to this one. So it's pretty practical, even though if I just drew this up here, you'd be like, hey, that's great, another textbook problem. You're going to run into circuits like this, and we can apply the voltage divider, and we should. Okay. I encouraged you when we talked about voltage supplies and schematics that if you saw these labeled voltages and if they were throwing you a little bit and you didn't know how to handle them, to redraw them as actual voltage supplies. So let's do that. Okay, we've got plus 15 volts with respect to ground, right? So let's say we got a ground out here. Okay, and we have negative 15 volts with respect to ground over here. So that's going to connect to this resistor. Okay. And minus 15 volts with respect to ground. So how do I want to draw that to get the polarities right? 12K, 48K. And this is V out. Okay. So I want to get the polarities right. So negative 15 volts with respect to ground. So I could write plus here, minus there, and then label it negative 15 volts. That would be one way to do it. Okay. So that the side with the labeled voltage is always on the positive side, and the negative side is always on ground. Okay. And this is negative 15 volts. So if I move from ground, which is 0 volts potential energy, over here, I've gone up, but I've gone up by negative 15. So I end up at negative 15 volts with respect to ground, thanks to that. Okay, so you got to think about these pluses and minuses. The pluses and minuses, you got to find good habits to get it right. Okay, so let's think about these two. These two look like they're in series. The ground, we'll have to think about the ground a little bit, but these two seem like they're in series. I can combine those into a single supply. So let's combine those into a single supply. And I'm going to make it plus on top, minus on bottom. And as I move from here to here, I'm moving down negative 15, so it's going to be minus negative 15 volts. Okay, and as I move from here to here, I'm going up 15 volts, so it's going to be plus 15 volts. So altogether, this combined supply is 30 volts. We'll practice some of those as we get into our second fundamental law of circuit analysis, which is coming very, very soon. Okay, hook that up to the rest of the circuit. And what we want to do is find V out. I guess I didn't write that. Maybe I should go back up and write that so it's on the notes. Right? Find V out. Okay, and I can't find V out. You're going to be real tempted to say, well, once I find the voltage across that bottom resistor, the 48K, 12K, 48K, you're going to be real tempted to call that V out. And that's just simply not going to be the case. Okay, but I am going to find the voltage across that resistor. Okay, let's call that R2. So let's find VR2. See if I can fit it above my head here. VR2 equals 30 volts multiplied by the ratio of our resistance. We want to find the voltage across the 48K, and we know that the 12K is in series with that 48K. All right, so we can calculate that. Let's grab a calculator, and let's say, turn it back on, 48K divided by 12K. Kind of missed the physical buttons of the calculator. It takes me a little longer with the mouse. 48K. Okay, and that's going to give us 0.8 of 30. Is that 24? 24. Okay. So VR2, I don't have room over here. So VR2 equals 24 volts. All right, 24 volts. Okay, so be careful. 24 volts is not V out. In the original problem, what we're asking is, what is the voltage at this node with respect to ground? Well, the ground is over here. Okay, so we're looking for this voltage. V out is measured here. That's where I would stick the red probe. I still have my probes here. I would stick my red probe. Can I reach it? Nope, my camera cuts off before that. I'd stick my red, darn, right? I'd stick my red probe on that plus sign, on the node that has the plus sign. I'd stick my black probe as my reference on the node that has the negative sign, which happens to be ground in this case, and that would give me V out. That's all fine and good, but what we figured out is that we have 24 volts here. Okay, so we have to think about this as potential energy. I'm going to take steps as I move around the circuit. Right? As I move from here to here, I'm going from low energy to high energy. I'm going up, but I'm going up negative 15 volts. Okay, so let's come down here and say V out is plus negative 15 volts. Might seem a little strange to do that, but I have the direction I'm moving across the voltage supply gives me the plus, and then the labeled voltage gives me the minus inside. Okay, and then as I move from here to here, I'm going up 24 volts again. Okay, so 24 volts. Okay, if we're thinking about potential energy, we're starting at ground, right? Where's my grass? Right, we're starting at ground, and as we move across that first supply, we go up 15 volts, and then as we move up across the resistor, we go up another 24. Or we go down. Right, we go up, but then we go down because of that negative. Woo! Okay, so there's our ground. We go down. Okay, the ball moves down first, and then it goes up 24 volts. So if this is negative 15 volts, and then this is, if we're measuring height in volts as if that's a reasonable thing to do, and this is positive 24 volts, how far above ground do we end up? Okay, and we end up 9 volts above ground. Okay, so V out in this case is 9 volts, and that's the answer we're looking for. Okay, so we might see voltage dividers with labeled, let's see if I can get my horrible ground picture above me. We might see voltage dividers with labeled voltages, and we don't be scared. Draw the voltage supplies in there, make the circuit look like what you'd expect it to. Okay, this one ends up looking like what we'd expect it to, and you can go find voltages from that. But then also be really clear on what you're looking for. If it's a labeled voltage, it's always in reference to ground, so make sure you know where that ground is. Okay? Where do we go from here? I think it's time. So voltage dividers can, there's all sorts of instances where we can apply voltage dividers. Over the course of the semester, I'll try to get you more. Certainly when we get to op amps, I'll point out a couple. Some people love doing circuit analysis around op amps with a voltage divider. I have a better way for you. But I will point them out because you can see them in voltage dividers, in circuits with op amps. And I'll make sure to point them out when we do that. But for now, we've kind of been dancing around the second fundamental rule of circuit analysis. And I think it's time that we introduce that. Okay? I'm excited. You're excited. Probably not, but just let me believe it, okay? Anyhow, stay tuned and good luck.